Myself Saurabh Agarwal from Tech University. I am in final year BA project. I am doing my project under CSIR SERC Structural Engineering Research Center, Taramani, Chennai. So my project title is Instrumentation and Real-Time Testing at Steel Plate Girder Bridge using wireless sensors. And we are doing this under the external guidance of Mr. K. Kesavan and internal guidance of Mr. Deeptikar Behra. Coming to the abstract part, as we know, a county of 40 major bridges collapsed around the globe due to insufficient health monitoring techniques. So, to evolve this major loss, we have tried to use the wireless sensors in the field of SHM, that is structural health monitoring, for acquiring the data from a safe distance, that too irrelative of the climate conditions, range and temperature. Now, as we come to the study area reminds us where the project is based, the topic where the project is based on. This project is basically based on advanced structural health monitoring techniques. So as to confirm that before and all we have used wired sensors which were expensive. The use of coaxial wires was hard to maintain contact, and that too very difficult to relate the data accordingly. The errors were more. Now, while the use of wireless sensors has reduced all these problems, the major thing is that we can install it in large scale structures also. With the help of this newly STS Wi-Fi product, all things have been possible. The STS Wi-Fi is produced by BDI, that is Bridge Diagnostics Incorporation. Coming to the scope and objective of overall study, what we have done, that is, first of all we have done the performance evaluation. Then after that, the planning of instrumentation scheme, how we are going to instrument the various sensors, various wireless sensors and the wired sensors for comparison at the same time on the real-time structure. Then the instrumentation part, after the instrumentation parts comes the experimental investigation, what we have done with the static and dynamic loading cases. Then after that we have done the analysis of the part, the collection and the analysis of the recorded data in the same STS Wi-Fi product. Then the result of the WinGRF and the Catman results are compared so as to confirm whether the use of wireless sensors in the field of SHM is reliable or not. The planned methodology, we can go on further, like we have started from the literature review part. We have studied a brief and about everything from the wireless sensors unit, as it was started in 1931 and still now it is progressing very fastly. The planned methodology starts from the literature review, coming to the study of wireless sensors, investigation on bridge details, the details of the bridge, then the experimental operation, what we have done there, then the monitoring of plate girder, what type of the plate girder what we are using, then the data acquisition system, how we are going to collect the data, in what manner, by the use of what sensors, and what will be the real problems we will be facing at the site. Analysis, that we have already told you that we will be doing the analysis with the help of WinGRF in this STS Wi-Fi product, and the results and comparison at the last to make it reliable source. General outline of the site where we have performed is the instrumentation is spanned in the middle and the two ends, that is the Arakonam end and the Renigunta end, where we have done our real testing. The instrumentation plan is this, that we have used various wireless sensors including the accelerometer to determine the vibrations produced as the test vehicle is moving and the dynamic loads applied at the same time. The use of strain gauge to measure the micro strain units produced in the bridge. Then we have used the LVDT, that is linear variable displacement transducer, to detect whether the deflection phenomenon in the horizontal and the vertical direction is more or less. After that we have used one more sensor. The last sensor is the accelerometer. So after the instrumentation has been done, the various tests load like the static and the dynamic tests were done. After the static and dynamic tests were done at the site, we have obtained the various data analysis part consists of various compatibility factors that we have obtained from various units and fractions. After that we were able to put that all things in the form of a graph with the help of this WinGRS software. After the test setup was completed, the first 3 tests were done for static tests, static loading cases, and the next 9 tests were done for dynamic loading cases. After the completion of all these tests, we have gone to the data analysis. Quarter arm strain gauge with respect to time, the maximum bending moment was obtained with respect to time in this, that was 121.66 ton meters. After that, the acceleration and frequency with respect to time were obtained. The maximum acceleration, that is vibration, occurred in the test setup was 0.048 meter per second square, and the frequency was 12.36, that is under 20 hertz and is under safe permissible limit in stresses. This is from the results obtained from the Catman software for the wired sensors, not the wireless. The next is the graph obtained from the WinGRS software for dynamic loading cases. The first dynamic loading cases is between the displacement versus time, that is with the help of LVDT again, and the maximum value that was calculated is 13.97 mm in the vertically downward directions. The other one, the test 6, was a quarter arm strain gauge with respect to time. The results of the same were maximum bending moment was obtained, that is 152.075 ton meters. Again we come to the dynamic loading cases in the acceleration versus time, and the acceleration versus time graph shows the frequency and the maximum vibrations obtained, that was 0.33 maximum vibration meter per second square, and the maximum frequency was 11.25, which is less than 20 hertz, so under permissible limit and safe stresses. These are all the results obtained from Catman software for wired sensors. Coming to the results of the maximum values obtained from different sensors, the maximum acceleration found is 0.042 meter per second square. Strain is 550 microstrains, and the bending moment due to that was 152.075 ton meters, and the maximum displacement in mm is 13.335. So here is the conclusion. So both the wired and wireless sensors were used in the field measurement for acquiring and comparing various parameters like maximum acceleration, strain, bending moment and displacement. Wired and wireless sensors are mounted adjacent to each other. Results of both were compared and found to be matching well. Hence, the wireless sensors can be applied for field measurements. And for the off-track records, the wireless sensors are free of temperature variance and hence no need for dummy gauges. Thank you for watching this video.